Hi, welcome to our sixth Zindi weekend, sponsored by Taskmate. Here's a video by Taskmate Taskers.
Yeah. Kenya ni inchi timamu, kila siku hapa ni karamu. Ukiwa na bidii utenda faa, bazen utashangaa. Kenya ni inchi timamu, kila siku hapa ni karamu. Ukiwa na bidii utenda faa, bazen utashangaa. Bazen utashangaa. Bazen utashangaa. Utashangaa. Bazen utashangaa. Kenya ni inchi supu, kwa Mkenya ni kujiamini tu. Kenya iko na diverse culture, Sheng ndio lugha tunabanja. Wakenya ni watu roho safi, mapeng wetu mali safi. Tunapenda kukula jasho yetu, kuhaso iko kwa damu yetu. Iko haso Kenya utaomoka, kwa Taskmate utakaogota. Masani ganji cheki mbota, Kenya ni bidii utatoboa. Utatoboa. Kenya ni inchi timamu, kila siku hapa ni karamu. Ukiwa na bidii utenda faa, bazen utashangaa. Kenya ni inchi timamu, kila siku hapa ni karamu. Ukiwa na bidii utenda faa, bazen utashangaa. Kenya ni inchi timamu. Kenya ni inchi timamu. Kenya ni inchi timamu. Kenya ni inchi timamu. Kenya ni inchi timamu, kila siku hapa ni karamu. Ukiwa na bidii utenda faa, bazen utashangaa.
Thank you so much, Amy. Really excited to be here today for the launch of the hackathon.
Cool. Do you want to? I'm going to add your slides. There we go. Do you want to tell us a bit about you and Next Billion Users?
Sure. So as Amy mentioned, I am Pratyusha Mukherjee, the India Partnerships Lead for Google's Next Billion Users organization. And the song that you just listened to actually has something in common with the data set that you will all be working on for this hackathon. So both of them were crowdsourced from hundreds of people using a new Google product that I'll be sharing about today called Taskmate. But before we get into that, let me first tell you more about what the Next Billion Users initiative is. We started this at Google to serve the needs of the next billion users of Google products, who will largely come from countries like Nigeria, India, Indonesia, and Brazil. More than 50% of today's internet population is in these markets, and by 2025, that number will be 75%. Importantly, the users in these markets are largely mobile first and mobile only. This means that they have unique needs and challenges when engaging with digital products and platforms. Our products seek to center their experiences. And because of that, there are two primary pillars to our work at NBU. First, we help other parts of Google address the needs of NBU users. And second, when we feel we can address an unmet need, we build early stage products, take them to market, and assess how users respond to them and whether they can be scaled. So at NBU, we believe that when we build for these users, we're building globally relevant products that work for everyone.
Can you tell us more about the data set that has been collected for this competition and why building inclusive data sets are important?
Sure. The fundamental issue with trying to build inclusive products very often lies in the lack of suitable data. If you don't have a data set that's truly reflective and representative of the underlying population, it's very hard to build products that actually satisfy these consumers' needs. Speaking from experience at Google, to more effectively build for our next billion users, we found that we really need to be able to easily reach and collaborate with hundreds of thousands and sometimes even millions of users around the world, which can be really challenging. Sometimes we might need a handful of people with specialized or regionalized representation. At other times, we might need a few hundred. We might need them for a project today, but then not again for 6 months. Recruiting these users, onboarding them, incentivizing them, and maintaining a high quality threshold can be a big challenge. And Taskmate, the product that we'll be talking about today, was really built to address that need. How do you quickly build data capture projects within a single platform and have hundreds of people from diverse backgrounds to build it out in a matter of hours? And that is actually exactly how the data set that you'll be working on for the hackathon was built. Almost all of the hands in the data set are hands of people of color, which was a conscious effort to address bias in sign language data sets that exist today. We will be offering this data set as a public good, open for all to use.
Thank you so much, Pratyusha. That was brilliant. And as you said, the data set was collected in a matter of hours, and it really was. We got nearly 9,000 images in the matter of a day, which is really amazing. Is there anything more that you'd like to share?
Yeah, I'm really looking forward to what our hackathon participants do with the data. Circling back to the song that you guys heard earlier, I'll just quickly touch on how Taskmate works and how it worked in the case of that song to put it together. So, really quickly, it's a platform where on one side you have requesters who could be businesses, organizations, startups, even NGOs. And these are the ones that need small tasks done. And the tasks are sent over to taskers, who are the people who complete tasks on their smartphones. So these tasks could be taking a picture of your hand making a sign, as it is for the data set today, or it could be translating a sentence in your local language, or verifying information about a business around you, or even doing a survey about a product or a service, and many, many more. In fact, in the case of the song that you heard earlier, what we had was two talented musicians, Major and Kutiman, who worked with taskers across the platform to collect over 1,000 different sounds, lyrics, and videos. And you saw examples of those videos during the MV that played earlier. And here I have just a quick sample of one of the guitar sounds that we collected from our taskers. So the musicians took these inputs, layered them together, and created that beautiful piece of art that you all got to enjoy earlier today. And this is precisely what we're so excited about with Taskmate, the diverse possibilities that it brings up in terms of collaborating across the globe, and bringing diverse representative perspectives to the table. And really looking forward to what we do with the hackathon, and build out the data set that we have on Kenyan Sign Languages today. If you guys are interested in using Taskmate yourself or in finding out more, feel free to reach out to us by email and we will follow up with you after the session today.
Thank you, Pratyusha. I know that Taskmate is in its beta stage, so really excited to see where it goes from here. Pratyusha is going to be on the line for the next 5 or so minutes, so if you have any questions or comments, please drop them on YouTube and I will share them with her to answer live. I just want to talk about the challenge today, reduced inequalities. So we're talking about Kenyan Sign Language. Kenyan Sign Language is also spoken or signed in Somalia. And there are up to, I think, 400 different sign languages around the world, including 4 different dialects, at least 4 different dialects in Kenya. The 9 different signs we have chosen to collect are some of the most common ones, such as church, mosque, temple, you, me, and friend. And the SDG, Sustainable Development Goal, we're addressing in this is Sustainable Development Goal 10. And we're focusing on the target 10.3, which is to ensure equal opportunities and to end discrimination. As Patricia mentioned, most of the images in the data set are of hands of color, so we really hope that this starts to level the playing fields. As Patricia mentioned again, this data set is going to be open sourced on Zindi, and we really encourage you all to open source your models and share them as a public good to the sector. I don't think that the impact of Zindi and the impact of Taskmate ends with this hackathon. We see this going forward and hopefully more taskers adding and more people adding to the conversation around sign language. I'm going to introduce Rose Wambui, a data scientist from Kenya, who has helped prepare the data and who has a starter notebook for us. Oh, and yeah. Welcome, Rose.
Thank you so much, Amy. I'm Rose Omboy. I'm in Kenya. I'm a data scientist at Zindi. I prepared a starter notebook that you can reference as you work on this hackathon. I will share my screen. As you have heard this data, we're using sign languages. So I did do a model on FastAI. So the first step I did was install FastAI. We have 2 versions of FastAI. So I'm using FastAI version 1. So when you install, it's always good to counter check what version you've installed, because sometimes you may have version 2 and your libraries in Python are referencing to that version. I'm using Colab. That's why I'm loading my Google Drive to read the data. Then you're going to import the modules. So we're going to use pandas. We're using FastAI. We're also using Matplotlib for visualization. And it's always a good thing to ignore the warnings, because some of the warnings in pandas don't really make sense, but you can ignore them. So I create an image path. All the images are saved on my drive under the name images. So when you're using FastAI or any deep learning tool, you can do data augmentation. By data augmentation, we mean you flip the data, you change the contrast. You can also resize the data, flip the data. So there are various ways you can do data augmentation in FastAI, in PyTorch, and also in TensorFlow. So these are the various ones we have done in FastAI. You can look at them later. Then we're going to read the train file. So the train set that you provided has the image ID and the labels. So you can see that from index 0, our label is a tempo, a church, enough or satisfied. me, love, and the various classes that Amy identified. So when using FastAI, we always load the data with image data bunch. For those who have worked with PyTorch, this is the same as the data loader in PyTorch. So you want to load the data in a format that FastAI understands. So we have our image path that we referenced here. This is the variable for the image path. Then the data frame. So this is the data frame. You can rename it to a train data frame for easier reading. And then we want to resize the image to 224. The reason as to why we do this, because for the model we're going to use, it's a pre-trained model, and most pre-trained models were trained on images with the sizes of 224 by 224. So always, if you're going to use a pre-trained model, ensure that your images are also resized to the same sizes that the pre-trained model were used. So it's always good when you're training a model to do validation. By validation, we mean you want to make an inference before with the training data that you have. It's a good practice because from the training data, you're going to get 20% of it and save it aside. And then when you train your model, you're going to make predictions of the 20 sets. And since you have like the solutions or the results, then you can compare how your model performs. So we are passing the transformation, which we defined earlier. And then number of workers. When you're doing Python, it's always good to ensure you have threads and multi-processing. So by this, we mean you want to utilize your CPU. So if you have like a Core i5, you want to ensure that it's using 2 of your CPUs. It's just a way of making your model run faster. Then the batch size is 8. So by batch size, we mean how many images do we pass to the model at a go. So for our case, we are passing 8 images at a go. And then we are passing the suffix here because our image IDs here on this file do not have a .jpg. So you can always do this and then you normalize the images. Let's say what number of classes we have in our data. So when you look at our data, you can always do data.c and then you get the number of classes, which have been stated earlier, it's 9. So we're going to look at the classes that we have. You can see for a chart, this is the sign. For a friend, this is the sign. For you, this is the sign. And for most, this is the sign. You can look at these signs here. And when you look at this data, could be because of the feed size, you need to ensure that the model is reading the sign. Because if you look at this U image, it's not referencing to the sign. So there are various ways you can do while you're cropping the images or doing transformation to ensure that you focus on the sign and not any other part of the body per se. Then our baseline model, we're going to use a ResNet 18. This is a pre-trained model. And yeah, we said it was trained on a 224 image size. So this is how you load pre-trained model in FastAI. So it downloads from the cloud. This is the model we have, and then you train it. So we're going to do 3 iterations. So you take the learner, which is the variable you gave to your pre-trained model, and then fit 1 cycle, and the number of epochs or iterations, this is 3. And this is the learning rate we are going to do. So when you train your model, you get something like this. And we can see that for the first iteration, the training loss was 3.1. For the second one, it was 2.6. And for the third one, it was 2.3. The same goes for the validation loss, the error rate, the accuracy, and the time taken to train that particular epoch. So in machine learning or deep learning, you see, as we go deeper in the number of epochs, our loss reduces and our accuracy increases. So we can see our accuracy at the beginning was 28, and right now we have 42. So another thing you can try, can you increase the number of epochs? It might take longer to train, but might give you good results. Another thing, you can change the learning rate. Try changing the learning rate and see what affects the solutions or the results you get here. And you should also be careful with the number of iterations. You may try to train for 50 iterations, and that can lead to overfitting. So look for various ways that you can implement early stopping ground, which means that I want to stop my model, I want to stop training my model at the first site of overfitting. And by overfitting, when the validation loss no longer reduces and starts to increase, then that means that your model is overfitting. So after you do that, you can predict on the test set that is provided. On this line, I'm loading my test set, and we can see our test set only has the image IDs on the folder. So we convert the tests DF into lists. So the first thing is also to read from DF. We are reading from this DF, and then also our suffix is .jpg, and the image path variable we defined earlier. And then you add to test. So this data is a variable we defined while loading the test. So in FastAI, you don't have to create another data bunch for test. You can use this, add test, and then it will take these new parameters for test. So where we had test df, where we had train df, we'll have test df. The image path still remains the same because all the images are in the same folder. And you can ignore this since we had suffix before. And then when you do that, we can see our predictions. Most of these models are predict in form of a tensor. So then we take the prediction test and Y prediction. We want to get our predictions. Then you can see the Y test here is in form of a tensor. So the next step should be to your submission file. So on Zindi, you're required to post a submission file or a solution file. So this line of code here helps you to take the predictions here into a submission file. So yeah, we are reading the sample submission provided, and it's provided in form of 9 columns. We have the image ID and all the columns representing each class. So yeah, from here you can do for I and C, you enumerate the number of classes that the model trained, which was 9, and then you can append this to your submission. So we have church, enough, seat, you. So this is what we have, that each image ID is referenced to all the classes. The reason as to why we are doing this, because the evaluation metric on Zindi is log loss. And log loss works in form of probabilities. So you're requested or required to post your solutions in form of probabilities. And it's highly advisable if this is 0.022, don't edit that into 0. We want the raw solutions that your model provide. And then now you can make your submission into a CSV and a baseline model. This is the baseline model we had. So we'll post this starter notebook on Zindi as well. You can look into it and try to perform more data argumentation. You can try other pre-trained model. You can also improve the number of epochs. You can also do TTA, which is test time argumentation. You're performing argumentation only on the test set. So you can research about this. And you can also try using PyTorch and TensorFlow. You're not limited to using FastAI. So I'll get back to Amy in case anyone else has some questions.
Thank you, Rose. That was really great. Rose and I will be staying online for another 5 minutes if we have any more questions. But really good luck with this challenge. We're really excited for it, especially me. And I'm really excited to share any solutions that come out of here. Good luck and enjoy. We will just be here in the background if we have any more questions.